Okay, this is Ed Doherty, your machine shop instructor at Suncoast Technical College, Haas Technical Center. We're using our Haas VF2 CNC machine. It's about a $100,000 machine. And we also have a TM1P and a lathe back there. But this is our Cadillac machine right now. And in here we have CO2 Dragsters. We've been making a couple. We got 5 done. We had one had a problem with. We got more material. We're on the main guy. This is main guy. This is the program. This is mounted in the 4th axis. So this is X-axis, Y-axis, and Z is up and down. And A is rotational. A rotates around X. This is in degrees. We set all our tools off of this wireless sensor right here. And we're using these 2 tools. This is our roughing tool. This is a 12 millimeter roughing tool. And this is a 6 millimeter ball end mill, spherical end mill. That's for making the nice contour cuts. Okay, so this is a very long program. I think it's estimated to run about 40 minutes. We did a time study on the CAD CAM system, and we loaded the program in. We have a graphics page right here, and this just gives a quick simulation of a bird's eye view of where the cut is, and this is all the code running in the background. Very similar to 3D printing, only we're cutting or subtractive manufacturing, and 3D printing is considered to be additive manufacturing. Alright, we've already tested this out in simulation in the CAD CAM, so we're going to just go cycle start and press the green button for cycle start. And we always have emergency. If anything goes wrong, you hit the emergency stop, and this is how we power it up. So we're just going to go cycle start, and this is going to start again. Here we go. It's going to rotate. Single block off, and optional stop off. Here we go. Rotates around so the left side is facing up. It's going to come down. I'm going to put it in single motion. So right now this is orientated at 90 degrees, and we're 50 millimeters above the center, and we're calling RZ0 the center of the CO2 cartridge. Alright, I'll take single block off. It looks like the correct position, and we'll start cutting. So it's going to start to work its way in, and this is considered to be a roughing operation. Eventually we'll start cutting more material, but the front of this car head is going to hop around. They'll start cutting the middle. There we go. It's starting to get deep now. So we do one side, flip, and do the other side. So when you're doing the CAM simulation, you can get the same view, just not the wood chips. And running all this code here. These are all X, Y, and Z coordinates. So right now it's running at 8,000 RPM at 3,000 millimeters per minute. That's our feed rate. So we come back along. This is going to show the whole tutorial, but I just want to give you an idea of what this part of manufacturing is, and in the end hopefully we end up with nice looking cars like these here. and this one was in from Riverview High. It was in competition. So we mounted on the center. That's your cartridge hole that was in the original wood. You have to keep it attached on the front because if you don't, that's what happens with this. This did not stay attached to the front, and it came loose, and it was very thin also, but we were able to do it. It's right here. So we had to keep it attached to the front, so you're going to have to cut that away with a saw and hand work that area. So when it comes to manufacturing work holding, we call this the work, is always the issue. Let me unzoom this a little bit. How do you hold this? You know? So we decided we're holding it through the shaft for the dragster propulsion area, and we're going to hold it on by the nose. And we're just going to say that we're going to need to, you probably could, if you could find a way to stand it up and mount it, it's possible to machine it from this orientation, only this might be kind of wobbly, but I'm sure we could just hand work that, or that's up to you guys. Okay. All right, so this side's almost roughed out already. So we go halfway on this side, and I can tell how far we are at because Z0B, the center, we're 14 millimeters above center, so it's working its way down. Okay, good luck.